Welcome to today's lecture, where we finally start our first ASP.NET Core Web API and explore the architecture within. So let's get started. So what we're going to do is that we're going to start our Visual Studio and create our first ASP.NET Core Web API. And let's see what files do we get when we start or when we create ASP.NET Core Web API and the files that we get by default. So we will explore them a little bit and discuss about what is the difference between all the stuff that we did before with console applications and now with ASP.NET Core Web APIs, and we will discuss each file in particular about what is the main purpose of it, why it is there, and if we need it or not. So let's navigate to our Visual Studio. So let's open up a Visual Studio, let's create a new project, and what you want to do is navigate to ASP. or write, if you don't have it, ASP.NET Core Web API. And make sure that you get this one, so not the native, not the F#, not the Razor pages, so ASP.NET Core Web API, and in the description you will see that it says a project template for creating a RESTful web API using ASP.NET Core controllers or minimal APIs with optional support for Open API and authentication. So let's choose that one. Here we can choose a name. Let's go with exploring API structure. Location, you can choose where you want to place this project. Make sure this one is clicked in. Place solution and project in the same directory. Click next. And here we have some different options to choose from. What we can do, we can choose which .NET framework or version we want to use, so 8 or 9. Authentication type, we will talk about this authentication type later down the line, but most of the stuff we are going to create ourselves. So we're going to implement or install identity platform or identity package ourselves. We want to configure for HTTPS. Again, we want to make this secure as the secure protocol, so HTTP is old-fashioned, and let's see, we want these ones checked in, so enable Open API support, do not use top-level statements, and use controllers. We want to use controllers. I will do a video about minimal APIs as well. They're quite fun, but controllers I think is quite suitable for everyone that wants to learn API and just starting, because they give us sort of a structure about how the API works and how it is meant to be taking care of different type of requests in regards to different type of models that we are working with. So that's why we will keep the controllers. If you want to find more about information about each checkbox, you can hover over the information icon here. So we chose everything when we press create. So when we press create, we will get the default window here that we want to close, and what we want to focus on is the right part here. So let's talk about what we get here. So what we get here is the following. So up here we have the solution, and as you know, those are the SLN files that we get when we create the project. So here is our project, so everything happens here. As you see, we can expand only this one, and that is the root of our project, so exploring API structure. So within here we have the following files. So what connected services are the external services our application is connected with. And oftentimes you will see that it will be some kind of integration with the third party like Azure. So most of the times you will see Azure stuff here. Then we have dependencies. So dependencies, as you may know, is the packages that our application is dependent on. And as you remember, maybe in our console applications, or if you did something on your own, you might have installed some packages like, I don't know, Fluent Validation, or maybe Automapper, or maybe if you work with databases, Entity Framework Core, and if you did maybe some styling with your console applications, as you probably used something like Spectre Console, or even the banners that I think the package is called. Yeah, I think its name is Figgle, and you have something like Colorful and a lot of different packages. So what you want to focus on is that these dependencies, they are the packages that we used in the, or something that our application is dependent on when we are building it and running it. So properties here has one JSON file, and what that is, I can zoom in here, is this. So what we have here is, so let's see what we have here. The first one is the schema, and this is so that it helps our code editors with IntelliSense, so that they understand what they can reference to us. Then we have IIS settings, and these actually, what it is for the server that, as we provide here, where it will run and on which port it will listen, or which secure port it will listen. So this is for the HTTP, and this is for the SSL port. As well, we have some authentication, where we say that we don't need to authenticate ourselves, and we can use anonymous authentication for this local server. And again, sorry, I jumped over. What we use these launch settings is for the local development of this project. So we have different settings here that helps our application run locally so that we can test it out in different types. Like we have here, we have different types of profiles. Here, and oftentimes you will see you always get the same settings. So you have the, or maybe not oftentimes the same settings, something that will differ is the application URL. So we have profiles here. So different profiles mean different settings. So we have HTTP, where, as you see, we have the some settings here. The most important that you need to remember is the launch browser. So that means if I navigate up here, you will see different kinds of profiles: HTTP, HTTPS, and IIS Express. Here, if I click on this drop-down icon, HTTP, HTTPS, or IIS Express. So these are the profiles, and when you have a launch browser, it means that when I click on this green button, or even in the terminal, write .NET Run, it will start my browser. So your default browser, and where it will navigate is to this launch URL. And oftentimes it will be the Swagger UI that you will see is actually a web page that contains all of the documentation of your APIs. So all of the API endpoints that we're going to talk about, as well as response and requests. You can test it out. You can send different types of requests that you have and see the responses as well. So you can test out how your API behaves. And where this HTTP will run is on HTTP localhost 5263. So that's where we can navigate in the URL in order to send requests to. And here is environmental variables. Oftentimes you will have different ones, as you maybe or may not know. Usually there are three types of environments: development, test, and production. You can sometimes find staging between test and production, but those replicate or represent different stages of development. Like in the development environment, we right now, so we are sitting and coding, and when we are finished, we would like to go further, right, with our development, but our code needs to be, let's say, production ready. But let's say that our code that we implemented, we are happy with it, but then we have the environments where if you work in a big organization, somebody else will take care of that code and test it out. If it behaves as well as on your local computer on the other environment, that is maybe connected to a test database. So if we say that the next stage from development environment is the test environment, in the test environment, all of your code or the feature that you implemented, let's maybe say that you worked on a login functionality. So you write your email address and password, or you try to log in, and on your local machine it works perfectly. But let's see if it works perfectly on the test environment, because test environment has maybe some other kind of settings, as well as it maybe talks to the test database, where maybe we have some other kind of settings as well. So we tested there, it behaves perfectly nice. Then we can set it to production, and production environment, as you know, is the stuff that people can see, like Facebook.com or Instagram or everything else, right? So it is something that users can already start using once it's in production. But there are phases to that, right? So here we can specify, and we can even on our local machine, if we want, access different type of environments and test out our code on those environments. So we don't need to wait if somebody else is going to do it. We can ourselves also do it right here. So these are the environment variables, and apart from environments, you can have most of the other stuff here as well, related to each phase or each environment. So we have HTTP, and then we have HTTPS. That is the one that we are going to use. So HTTPS, always with the secure protocol, right? So again, we have the launch browser, we have the launch URL. It will start the Swagger UI, so a web page that contains all of the information about our APIs, and it will run here. So 72 HTTPS localhost 7208. And we have some environment variables. And here we have the IIS Express settings as well, or the profile. So you don't need to worry much about this file, especially as a beginner, because I can guarantee you that you will not touch anything around this part. The most interesting thing is this one. So HTTPS, because we're going to use it, and the application URL, where it runs. So that's important for us. Because this is going to be the root or the base URL, if you remember from our anatomy video. So base URL, where we send our API requests. So this thing, so this HTTPS localhost 7208 is the address where we are going to send our different API requests. So that's the most important thing that you need to know about the launch settings.json file. Okay, let's go to the other side. So now let's talk about the app settings.json. We can talk about controllers later. We don't want to jump into those yet, but let's talk about app settings.json. Here is something really interesting. So app settings, it gives it away, right? So application settings. Here we're going to have some kind of, oftentimes, secrets that we are going to keep, right? When we start and connect it to a GitHub repository, so when we connect it to GitHub, we will have a git ignore file where oftentimes app settings.json is being ignored. And but even if it's ignored or not, you will get an error from GitHub nevertheless. But why this file exists is so that we can put our different kind of secrets and variables inside here, so that the entire application can know about them. We can easily access them. We don't need to copy paste in different places. We put all of them here, and when we need them, we only reference to this file. And oftentimes why I said in the beginning that you will have secrets here is because you don't want them showing up in the code, right? You don't want other people to see, like for example, your secret API key, right? That you maybe bought somewhere, or maybe the connection string to your database, right? Because they can hack it, extract the data and so on, maybe destroy your database. So that's why we want to put them here. So we put them here, reference them with key value pairs, right? Because this is JSON, and then reference it with the key inside whichever file in our application. So that's the point with app settings.json. Again, short, explained in short terms. Here we put all of our sensitive information, secrets, variables that we maybe don't want to see or don't want others to see, and that we want to reuse in the entire application. So we don't want to copy paste them all of the time and have them in our code. We want to keep them here. So that's the main point of app settings.json or application settings.json. So that's sorry, I forgot to, let's switch to this part of the screen. This is how it looks. So here we're going to keep our key value pairs. Like here, it recommends me directly to have some kind of database connection string. And then you can put your my secret connection string, for example. And here I can reference that in the entire application if I wanted to. So that's the main point. Let's go further. Next file is this one, HTTP, so .http. And the first part, of course, as you see, is the name of our project. So if I open that, you will see that it opens this. And what this is actually is only the visual representation in a text format of all of the API endpoints that my application has. And right now it's only this one, weather forecast. So I have a GET request registered on this API URL or this API address, right? So endpoint. And that's true because if I go to the controller that I'm going to explain in detail further down the line or in a couple of minutes, you can see that here I have a GET request, so HTTP GET, on the weather forecast controller. So that's why I see it here. So I have a GET request on the weather forecast controller. And you can actually send a request here, but you can only send a request if our application is running. So right now you can see that no connection could be made. But if I start my application, and you will see that I will get a window that is Swagger. I will show you as soon as it comes. It comes here. So here is the Swagger UI. That's the web page that I've been talking about that is going to show directly when we start our program. And here we can see all of our API endpoints that we currently have in our application and the only one that is registered is the GET endpoint or the GET method to this weather forecast address. And what you can do here, you can try it out, you can execute this, so you can send actually a GET request to this address and we get some response here. And we will see how that works in just a minute. But again, let me, because I started it right now, let me show you here. You see that localhost 7208 Swagger, that's where the application run or started, and that's the, or if we go back to launch settings, that's this one. So HTTPS localhost 7208. So that's where it runs. So that's important to know. So sorry, I meant to show you that you can explore your APIs here, but you can also send a request from here. And as you see now, we have a 200 OK response that has this body. So this is the data that we get back from calling or sending a GET request to this address. So, but this is rarely used. So you will rarely use this this HTTP file here. Oftentimes you will use the Swagger, or as I'm going to show you later on, a Postman tool that is quite useful. So that was the HTTP file. By default we get this class. And this class is the weather forecast that comes by default. And if I expand the controller, you see that we have the weather forecast controller. And that's the main point. So as well, this is not it actually is dummy data, but they did it on purpose because they will also like to show you a pattern that most of the developers use, and that's that you will have a class, that is this one, and oftentimes you will have the respective controller with the same name. So weather forecast controller, weather forecast. Because this is a class, right? So we have weather forecast. Let's say that we have a book, and what we will have in the controller is all of the create, read, update, deletes, right? That we talk about. So most of the times, if you have a model, or if your application is, let's say it's about cars, right? So if you want it to be around cars, let's say car is built of different parts like engine, tires, and stuff like that. So your logic, like main logic of the, let's say, building a car is buy an engine, or create an engine, update an engine, delete an engine, stuff like that. But you will oftentimes have create, read, update, delete, right? So that's the main thing here, that they want us to use a class, and from that class we create a controller that has all of the create, read, update, deletes, right? And create, read, update, deletes are going to be get, post, put or patch, and delete, right? So that's the main point. And here we get this one by default, and in our weather forecast controller here we have the following structure. So how it looks and how it always will look is that you have an API controller and it has a route. Route is the first part of the address. So let me show you again. We know that when we start our application, right, it exists or lives in HTTPS localhost 7208, right? So if I start my program, it's here, right? So if I want to set a GET request, I will send it, and you can see here that I have HTTPS localhost 7208 / weather forecast. So / weather forecast, if I take all of this, and I can as well just open a new tab and paste it here. If I press enter, I send a GET request. And as you see here, I get the same response in the web browser. So I don't need this actually for the response. So I can send a GET request by navigating, as we talked about in the beginning, navigating to the URL and only pressing enter. So I send a GET request. And I get this response, right? So this is the URL that, or this is the address of the GET API endpoint. And right now, if we go back to the controller, here, I can close this once, we see that the API controller has the route of controller. And what that means is that we will take our HTTPS localhost 7208 or whatever it is and add weather forecast on it, because that's the route. So it will add that / weather forecast that we had. It will take away this part, the controller, as you see here. So it will take away this one, and our route, when we want to address everything, so all of the create, read, update, deletes, if we want to address them, they will exist in HTTPS localhost 7008 or I don't know / weather forecast. And then I will show you we can adjust or manipulate this as we want. So let me show you. Right now we had it like, or I can show you, I think we have it live. So we have it localhost 7208, right? So we have it there. Let's close it and let me write API / demo sensei demo, for example, and then let's save it, and I want to run it again. So look at this here. So now where it exists is localhost / API / Nemo Sensei demo / weather forecast. So if I execute it, you will see here that right now, if I want to send the GET request, I can send it to this address. So localhost 7208 API Nemo Sensei Demo weather forecast. So I send it here and I get the same response. So you as a developer, you can manipulate the address. So as we said, address, URL, endpoint, you can manipulate what it's called and where it lives. So, and oftentimes you will only see it like this. So oftentimes it will be API/controller so that it knows that it's an API. Because if we talk about full stack applications, you will oftentimes have a front end, right? Like built in different type of frameworks like React and Next.js. And you will have a routing there. So let's say that if I navigate to Nike.com, I want to render a page. So I want to show a page that has these visual elements. And that is the React part. So that is the front end part. Data maybe and everything else will exist, or it will get from our database and API that we are building right now, right? So that's how we show the data. So that's why we want to like separate Nike.com/shoes with Nike.com/API/shoes. Because we know that if we call or if we send a GET request to API/shoes, then we get all of the data as a JSON format, right? All of the shoes as a JSON format. But if we navigate to Nike.com only, so /shoes, then we get the data as a JSON, but we show it in a nice modern way with all of the visual elements. So that's why you will oftentimes see an API in the prefix here. And the rest is pretty easy. We have only a class that is the main model name with controller added, and it inherits from controller base. Controller base, as you see, is a base class for MVC controllers without view support. So we inherit from this one so that we can use all of the properties and attributes that MVC controller has, and those are all of the attributes as well as the HTTP methods that we are going to use for our create, read, update, deletes, right? So here we only have even here we don't use this, as you see, logger. If we double click it, we only have it in the constructor here, but we don't use it anywhere, so we can remove that. So what we have is only a string array that has summaries that returns different kind of information about the weather. And then we have the HTTP GET request that is called get weather forecast. But what this does, so let's talk about how this is structured. So if we go back, we have to go back. We have the address, right? So localhost 7208 /API/weather forecast, right? So when we navigate there, or when we go to that address, we can execute only this HTTP method, right? Because this exists in, so I can even remove this because it's only the name. So I can only send a GET request to this address. And let me show you what I mean. So if I navigate to that address, and here I don't add a new route, I only use this one. So I only have the GET request. It will go to that address, and if I send a GET request, it will run this method. So this is the method, so public array of weather forecast class or objects will be returned here. So we have a date, we have a temperature, and then we have summary as a response. So this is the, if I run it, this is the response that we get when we run, or where we call the GET request to API/weather forecast. So this is the response: date, temperature, Celsius, Fahrenheit, and summary. So this is this. So, and if you see date, temperature, summary, you can ask yourself, okay, wait, where is the Fahrenheit? If we go to the class, temperature Fahrenheit is 32 plus this calculation. So it is automatically generated. So here we have 3 properties, but if we go back, you will see that the weather forecast has 4 attributes, and the fourth one, temperature Fahrenheit, is calculated automatically, just if you want to understand what's happening here. So, and this exists as I said, on this URL. So https localhost 7208/API/weather forecast. That's the URL here. But look at this. I can do HTTP GET again, and I can add my own little suffix or text, or we can say I want to adjust the URL or the address or the endpoint so that I both for myself and maybe the user or everybody else show what I want to do here or what this API method does. So look at this. If I say that this method, let me change the keyboard. So if we say that here we want to do return name or return Nemo name. So if I do it like this, and I can have a public method that returns a string that is called return Nemo name, I can then do this. Return Nemo is my name. So I created a new HTTP GET request, sorry, only one request, so HTTP GET request that exists in API or localhost 7208. I want to go through that again, so always remember the root address /API/weather forecast, and now it's going to be /return Nemo name. So if I run this and I show you here, then we have a API request, a new one. You see that we have two now. API/weather forecast/return Nemo name. And if I try to execute this one, you see that I get back Nemo is my name text. So it is that easy. So most of the times what developers or students trying to learn this is they're trying way too hard to understand the entire architecture, and they oftentimes think that it's much complicated than it is. But if we go back and think about this, we have an address. So this is the address, https localhost 7208/API/weather forecast/return Nemo name. So this is the address. What we need to do, or what we can do, is ourselves decide what the address name is, the entire address. And oftentimes, as we said, we want to have API will always be there. Then we have the class name. So if we have book, then we can have create book, delete book, update book, and get all books, or get book by ID, right? And it can be like this. So books/get book by ID. And then if I call this, of course, I expect to get back a book with ID. So the entire logic behind the API is that you have an address. If you get that address, or if you match that address with the API method, so request method that can be get, put, patch, post, or delete. So if you match the API method with the URL or the address, you get, or the respective method that you wrote underneath it is going to be executed. So if I have here one more HTTP GET that is, for example, book by ID, or we can call it get book by ID, then I can return, or I can call it get book by ID. Sorry, I don't need this one. So again, the main thing is that you match the address with the endpoint or with the API method, and when you match it, then this method that has this connected to is going to be executed. That's the entire logic behind APIs. And of course, once we start learning about more advanced stuff, as well as connected it to the database, learning about services, learning about different patterns, involving some new packages, then this part, the return part, is going to be more and more complicated. I don't like the word complicated because I think programming is quite easy. You only need to follow. It's like baking or doing anything. You just follow a recipe, right? So there's a lot of recipes. You can decide whichever you like and just follow it. So it's that simple. Same thing as that's why I like to say it's the same thing as programming. Like, you don't. Everything already exists, especially in the programming world. So you cannot, if you really can come up with something new, then you are set for life, my friend, or you can make a lot of money. But oftentimes we, as developers, we try to solve problems from reality, right? So create applications, create websites, create different apps, create some kind of a solution to some kind of a problem, right? And oftentimes it already exists. It maybe needs some kind of adjusting, right? So that's what we do. And that's what programming is. You oftentimes will find that somebody already did what you are trying to do. Like, for example, library example. Like, you want to create an application that is a library with all of the authors, books, and different stuff. Check out book, you return a book, like create all of the entire application. I can guarantee you that you can find like thousands and thousands of GitHub repositories doing just that, maybe in different programming languages. So it's not that you're going to be the first that created that. And that's with a lot of different applications. So APIs, I want to go back to APIs. It is relatively easy. So as you see, we got a lot of different stuff by default here. And the only thing that is important for us is that we know that controllers are going to be our create, read, update, delete places for a certain model. So if the model is book, we have a book controller with all of the create, read, update, deletes. That's the only thing. And inside that, we need to match the URL, so the address where we send our requests. So we match the address with the method that we want to be executed. That's the entire logic. So it's not complicated. It's not more complicated than that. So when you understand that, it's going to be relatively easy for you to develop whichever type of APIs. So that's the main logic. Match the address with the HTTP method so that this method is running or will run. That's the entire thing. So if we show just for fun, we have a new get one API, weather forecast, get book by ID. And if I try it out and execute, I get this is the book with ID 1. So I get back that as a response. So, and as you see, it registered that each one of these is a GET request because I specified it here. I cannot have, if I delete this part, you will see that right now I have two GET requests that live on the same address, that is the localhost 7208/API/weather forecast. So when I run this, I get here. So error. Failed to load API definition, and that's because so if I run it here and I have this error, I can go through my let's see, copy this and go to weather forecast. I don't get anything because it doesn't know where or which one to execute. So you get an error. So you cannot have the same address for the same method that does different things. What I can do is have this. I can have the same address but for different HTTP methods. So if I run this now, then you see that it registered that I have the get and the put on the same address. But again, they are different methods, so you can have them on the same address because they do different stuff. So one is a get, one is a put. You can have delete, you can have patch, you can have post on the same address. So that's important to know. You can have the same address with different API methods, so HTTP methods. That's important to know. But oftentimes, for readability purposes, for whatever it is, to have it more clean and understandable, oftentimes what I prefer, and I see most of developers prefer, especially young developers starting with their career, is something like this. Of course, it will not be weather forecast, it will be book, but if you see that address that is API/books/getBookById, you know what it does, right? You immediately know what the logic will be behind the scenes. But if I have get API weather forecast or put API weather forecast, I can only guess, but I will definitely have to go into the code and look what is happening. But here, if I have API books, get book by ID, I already know what's happening, right? So for the readability, for clarifying what you're trying to develop and to have it more understandable for everybody, use something logical for the naming convention. That's as easy as it can be. So that is for the controllers. So we decide the address, we decide the HTTP method, we decide what we do. So that's the entire thing with controllers. And at the end, my friends, we have the program.cs. So that is the most important file that I wanted to explain to you at the end. Actually, I cannot say that it is the most important one, but don't think that it is the most complicated one, because if you did console applications, which I know that everybody did, especially if you started learning .NET, you will know that everything runs in public class program and public static void main. So here is where the magic happens, as the cliche says. So everything that happens in our application is here. It needs to be referenced here. So let's only what I want to explain to you before we didn't start writing code right now. So when we start writing code, I want you to focus only on this. Code, if you noticed it, is more and more like writing words. There is rarely few mathematical equations or stuff that you need to write, that you need to remember, but oftentimes code is most likely to be just writing words. So please try to do it like that. When you write code, try to write it in that sense that it is self-explanatory with the, for example, like I did here for naming conventions of URLs or the addresses, what the methods does, what the variable name is, and stuff like that. Because if you have it like this, like books, get book by ID, and then this method runs, I know what's happening, right? So I don't need to be actually a developer to know what is happening behind the scenes. So always try to do it like that, because as I say to my students, if I wake you up in the middle of the night and ask you, hey, what did you mean by this? Or what did you write in this code? You will only have to read it, so only look at it, and you will know exactly what you did. So that's why oftentimes I always go back like 1 year before, 6 months before, even maybe a longer period back and see how did I write code. Am I satisfied with this? Because of course you will learn a lot of new things down the line, but cleanness of the code, like readability, is the most important thing. So that's why we need to learn the grounds right now, how we code clean, in order that we can scale and learn a lot of different things to implement. But if you have a stable ground, you can build upon it easily, instead of having just a big mess and then piling upon that mess. It can really easy just crash. So naming convention of everything that you work with. And nobody says that this method, for example, cannot be here is where Nemo explained that the book with ID 1 is getting returned. So nobody says that it cannot, that this name of this method cannot be what I wrote right now. So you decide, you as a developer, you are writing code and you need to understand that, you need to know what you are developing. Oftentimes what I see is that my students, of course everybody uses chat, and the chat likes to use abbreviations, so they know it right then what they did, but if I ask them even a half hour later, God forbids 1 week later, they will sit there and they don't know what they're done, what the method does. So please use chat, but make sure that you understand what you're asking from chat, the response that you're getting from chat, and that you adjust it so that it is that you can always understand, even if you go back 1 week, 2 weeks, 6 months, 1 year back, that you understand what it is that you wrote in that method or in that part of the code. So again, you can write whatever you want when it comes to naming convention so that you understand it. So let's go back to the program. So here, if we only read what is happening here. So in this line, we have the builder variable, that is the web application create builder with arguments. Something that you as the developer need to do is this. So hover over an object or a method and it will have explanation, a short explanation directly underneath. So what the web application here is, it is used to configure the HTTP pipeline and routes. Create builder initializes a new instance of the web application builder class with pre-configured defaults. So what we are doing here is we are creating an object of the web application class. Really easy to understand, right? And these arguments are the pre-configured defaults. Nice. Here, so what is happening here in the builder part? So builder. Here is something that is called dependency injection container. So, and what dependency injection actually is a technique. You can think about it as a technique or a pattern in ASP.NET Core that provides the services or dependencies, again, something that your application is dependent on, that provides them here. So we specify with the builder.services, as you see, what our application is dependent on. So we reference our packages or different kind of methods or services within our application inside here, so that we say that our application, when we are building it, it needs this stuff in order to run, right? So whenever our application needs something, needs a service in order to run, we specified it here. And right now we don't see stuff that you will usually see. I will show you in a minute. But here we have 3 stuff that always we get by default. These are the controllers, right, that we use here. Endpoints API Explorer is important. It configures API Explorer using metadata. And then we have Swagger generation. And this one is from the Swashbuckle package. If we double click, I forgot to mention that. So if you go to the root of your application here, or the name of your application, double click it, you can see that here you have property groups, and you have the target framework that you're working on. You have some other properties, and you have packages. So you will have, each time you install a package, it will be visible here. And you can see which package you have and which version of the package you have. So here we have this Fashpackle, that is this version. And if we go back here, we can see that this is where it comes from, this Swagger generation. And it will generate the UI and all of the register all of the endpoints that we have, or all of the API controllers and endpoints and actually addresses that we have inside the Swagger UI that we use here. So those are the three ones. Most of the times, I want to show you visually here, you will have these three. So you will see these three. And what they represent is that the services that we want to use, each time we reference them, we want to create an instance of them. And when we decide to have them in the builder.services, we will use some of these ones. Of course, database and other packages have their own setting of how we reference to them, but the stuff that we create are going to be these three. We're going to use these three. So singleton, it will be a single instance that when we reference them, we only have a single instance throughout the application's lifetime. So when you click on the green button, or if you deploy it, so as long as it exists, it will have only one instance of whatever service that you are working with, and that's the singleton. If you want to learn about singleton, you can learn about it in the design patterns. The next one is the transient. So transient is that a new instance is created each time it's requested. And finally, we have scoped, that is that each instance or a new instance is created per each HTTP request. So let's try to explain with an analogy. So singleton, it's a single instance that is shared throughout the application's lifetime, right? So what it is one coffee machine for the entire office. So you can think about that. So in the office, you might have one coffee machine in the break room that everybody shares, right? So it's always there, it's always the same machine, whether it's morning and different type of stuff. So a singleton service has exactly one instance for the application lifetime. So every request, every user, every piece of code uses the same exact instance. And oftentimes the main singleton service that you're going to use is the database, right? So everybody works, or everything that you do will be registered in one database, right? So whichever user, whichever model, books, authors, whichever model, everything is written in the one database, right? So in the same database. So that's the singleton. Let's look at the transient or the scoped. So for the scoped, we have a new instance created per HTTP request. So one waiter per table or session. So think of a restaurant. So when you sit down at the table, you have a dedicated waiter for that single meal session. So if you request more water or dessert, the same waiter helps you. However, when the next group sits at the table, they will have a different waiter. So what the parallels or what the scope service is, if we look at the code, is that a scope service is created once per request. So like for your entire dining experience, everything in that single request or session shares that same service instance. So once the request is over, the waiter, that is the service instance, is no longer used, and a new request gets a new waiter. So that's the scoped. Okay? And at the end, we have the transient, and the transient is a new disposable cup each time. So this is quite a nice analogy. So imagine a snack station at the office with a stack of paper cups. So every time someone wants water, they take a brand new cup and then toss it when they're done. So the next person always takes a completely new cup. So in the code, each time you request a transient service, you will get a brand new instance. So it's created fresh for every use, even if multiple uses happen within the same operation. So what it is, you can drink multiple times with the same cup, but as soon as the new person comes, they take a new cup. So that's the transient. And oftentimes these three you will have in the dependency container here. So when you register your services. So what you need to do, what you need to know is that what type of service do you use and how it will work. So database, everybody, transient, scope, you need to know about what architecture, what type suits your application best. So that's something that you will have to explore on your own hand, depending on what type or what nature of your what nature your application is. So again, if we go a step back, everything here, as you see with the comment that we get, is that we are registering in this service container or dependency injection container everything, every service that we want to use inside our application. And what we do here on the next line is application. So we created application that is builder.build. So we created application. Here, all the way until we run is something that is called the pipeline. So pipeline, again, it is a little bit self-explanatory, but you can see that once the HTTP request comes in, so once it comes in, everything down the line will use and will or can use all of this, right? So these are the middleware or the instructions on how our HTTP request should behave. So what kind of different steps it needs to take or it can take in order to be executed. So for example here, when we look at it, we can see that we have an if statement. So if the environment that we talked about before, right, if it's a development, then we can use our Swagger UI. And that's the web page that we have been seeing, the green one, where we see all of the registered API endpoints. Then we have something that is HTTP redirection, that as we see here, it adds middleware instructions for redirecting HTTP requests to HTTPS. So making HTTP requests to HTTPS, right? Redirecting them. Then we have authorization. And authorization, if we as well read, it adds the Microsoft ASP.NET Core authorization middleware to our builder or to the application, which enables authorization capabilities. So what we can do here directly with only this middleware or this instruction, we can set, I can show you as well how easy it is. We can set a authorize attribute here that says, right now we will get an error because we don't have any authorization settings in place. We only have that we want to use it. We don't actually say how we want to use it. But if I click on execute, you can see that I get no authentication scheme was specified, so I'm not authenticated. So that's basically what it says. So, but once I have the authorization setting in place, that I will of course write here. So if I have that setting or those instructions that I, for example, say that I am authorized when I have a token, or I'm authorized when I log in, or I'm authorized if my name is Nemo, for example, then I can go and actually send that request. So that's what authorization is helping us. And we can do that only by setting this attribute here on our HTTP method. So it's that easy. And that's how we protect our data and our endpoints from users that are not registered, not authenticated, not logged in, and stuff like that. And at the end we have map controllers, and it adds endpoints from controller actions in the to the endpoint route builder without specifying any routes. So what I'm trying to learn you here is that, as you see, there's basically there's not any code here, right? Everything is words. So builder services add controllers, builder services add API endpoints, app builder build. Like, you see how there's basically no code, like old school code here. Everything is words. And that's how I want you to code as well. So when you further down the line, when we start coding, you see that maybe here, yes, here we have to say that this is a HTTP input, authorize is a word, public string, so public method that returns a string, and this is the name. Everything is words, right? So what it needs to return, this is what it returns. So it's quite easy to program. You just need to, from the beginning, adjust your thinking capability or thinking way, mentality to that. You will try to write code as clean, as readable as possible. So that's why I'm going to, each time we start writing code, I will emphasize on that. I will always emphasize on how important writing clean is, because everybody can write clean, and whatever time has passed, you can always go back and say, yes, I'm quite satisfied with that code. Because again, we as developers, only thing that we do and the thing that we are paid for is solving problems, but what we leave behind us when we are done with the job is the code. So that is the product of your brain, like you wrote that. So you need to be satisfied and proud of what you left behind you. Why? Because that's the best advertisement for you. That's the best way that other people know how much value you bring to the company. I don't care about the company, but how much value you bring to the application, but as well to your colleagues. Because I can guarantee you, if you write clean, so if you write readable code, the entire process of somebody looking at your code, reviewing it, approving the pull request, discussing your code, it will be so much easier for the entire team, and everybody will be thankful and satisfied that you are their colleague. I guarantee you. And that's how you bring your value up. And I can guarantee, as soon as other developers notice, and they will notice soon if you write clean, the management and everybody else will notice as well. And again, your value, your salary, your position in the company, everything will rise exponentially. I guarantee you, because I have a lot of my students that did the same thing, that were students and jumped directly to a job, started writing clean, and kept their position on writing clean. Even if everybody else wrote shitty code, they kept their position and they swim to the top very fast. So I guarantee you that that works. If you bring value with clean code, it will be noticed. So let's go back here. So again, everything in Program CES is basically, we have a builder. When we build our application, here we specified our services, so our dependency injection container, everything that our application needs in order to run. Then we configure this middleware pipeline. So don't be afraid of these words. If you break them down, you will see that these are basically instructions on how each HTTP request should behave when it goes through each step or through multiple steps. So here we specified how we want them to behave. And at the end, we have this application that run. And that's it. That's the entire ground setting or architecture of each API project. So what we are going to do in the next lecture, we are going to remove this. So we are going to delete the weather forecast controller and the weather forecast class. And what we are going to do, I will not do books and stuff like that. Let's do something maybe a little more interesting. We will start with create, read, update, delete of a certain class. And we will implement that, and we will implement it with a dummy database. So we can say only a list, a fake list. And then in the next lecture after that, we will connect it to the actual database. So that's what we are going to do in the further lectures. So thank you for today, and I will see you in the next one. And before I forget, if you have questions, if I maybe mumbled some important part, just write it in the comments and I will help you out. And as well, I know that in the first 2 videos my sound quality was disastrous, so I think it will be much better now. So just give me feedbacks on what I need to do better and I will do it, because again, I'm here to help you. Thank you for today and see you in the next one.